We're good.
Good? All right, so logs. Marcus, need to have the voice off, please. Nancy, Alfredo. Logs. So what I want to think about here is we've already seen the graphs of logs, what they look like. But I want to delve a little bit deeper into why they look the way they do. So we have y equals log of x. Right. All of these graphs have the same general shape. The base is just different, but the general shape is the same. The base is different, but the general shape is the same. Now, one thing Khan does very well is he's like, the way to build out this graph, if you had no idea what the graph looked like, I would build it by making a table. But he's like, it's really hard to build the table this way. Victoria, know me what's going on. Victoria, you need to turn your body. Thank you. So, Khan said it's much easier, rather than trying to plug in here, to build out the graph as follows. Imagine this is a 10, and you're just sort of going to build this here. 10 to the y equals x. We know these things are the same. We know these things are the same.
3? Off 3?
We're not on 3, we're on the top.
No, I'm asking, is that a 3?
That is a 3, yes. Marcus, is it helpful to come in the front to see better?
No, it's just
No.
I can see all those, I just can't see what that was.
No, I'm just saying, so if you sit here, you might be able to see everything. There might not be a risk, right?
I can see, I can understand the handwriting.
I see. So 10 to the y equals x. So Khan says, imagine I plug in 0 for y. This is the new part. Most times we plug in x values. But Khan is like, might be easier to plug y in. He's right about that. It's very easy to solve this now. 10 to the 0 power, we all know is 1. 10 to the first power, we all know is 10. 10 squared, we all know is 100. This is a very easy table to build by plugging in for y. So let's graph this, see what it looks like. So we've got x equals 1, y equals 0, that's here. X equals 10, 10. Y equals 1, that's here. And then x equals 100, that's way over there. Y equals 2. I'm not going to draw that, but I will just basically indicate that this is a really flat graph, but it is still increasing. At a very slow rate, but it is nonetheless increasing. Yeah. It is nonetheless increasing. Any questions on how we built out this positive side above the axis so far? Let's build the negative side.
You just moved the 10, right?
Help me out.
You moved the base, right?
Yeah, exactly. Right. Yes. Now, what if y is negative 1? If y is negative 1, then I have 10 raised to the negative 1 power for x, which is equal to 1 over 10 to the first power, which is equal to 0.1. And remember, if I have a negative exponent, we talked on Monday, exponent rule says bring it downstairs. If I plug negative 2 for y, I get 10 to the negative 2, which is 1 over 100. 10 squared is 100. That comes downstairs. And over here, 0.01. So negative 1. So when x is 0.1, that's like right here. Y is negative 1. So 0.1 come down to negative 1 right here. When x is 0.01, that's like super, super close. Y is down here at negative 2. And now we begin to see what happens here. No.
What did you rewrite the second one as?
Second one? So it's a 10 to the negative 2, which becomes 1 over 100. Because this becomes 1 over 10 squared so on. Okay, now we have an interesting point here. Why can't this graph come on this side? Why can't the graph come to the to quadrant 3? Let me, what do you think?
Because the x's, can't go to negative, it can only go either a whole number or a fraction.
So why can't x go to be a negative number? Rob here?
Is there anything squared have to equal positive?
Anything squared does have to be positive, but I can put anything in for y, right? So it's not just squared. I could do it to any power. Well, why can't we come into quadrant 3? Victoria Bernal?
I forgot the information, but it was something about how it can't equal 0. Like
What is
for
it?
the y-axis.
Right? So would it be intuitive if I said there is nothing raised to a power that will ever be 0? Nothing raised to a power can ever be 0, right? If and only if, I mean, the only exception is if this were 0. We don't have that. That wouldn't even be a function.
Oh yeah, 10 to the 0.
10 to any power you can never have 0.
No matter what the coefficient is.
Coefficient.
Coefficient.
This number, the base.
Yeah, no matter what the base is.
Yeah. I mean, it's not possible because I'm multiplying numbers together, and none of those numbers are 0. So I can never get 0 as the product. 10 squared is just 10 times 10. 10 cubed is 10 times 10 times 10. It's never. I could never multiply anything to get 0 here because there are no zeros in there.
And then 10 to the 0 power is 1. Right?
And 10 to the 0 power is 1. So we have a vertical asymptote at x equals 0. Have a vertical asymptote at x equals 0. Now we have an interesting question. We have a very interesting question. The question now is, how is this graph, y equals log base 10 of x, different from this graph, y equals log base 3 of x? That's the interesting question. Anthony?
It's a different base.
It is a different base, I agree with you, but is the shape different, the same? I don't know. You can answer this if you know. I don't know. Jennifer, what do you think?
I think they would be the same because if you switch it, you would have the same equation you have at the top. So you would
What do you mean by
also have,
switch it?
like if you put like you know how you put 10 to the y equals x.
Right.
I have a feeling that if you do that too, you'll also have a vertical asymptote of x equals 0.
So let's find out. Mr. Ramirez?
Anthony's going home.
Okay. So this can be written, I think by flip you meant write it like this. 3 to the y power must equal x. So let's plug in values now for the purple table. Have a great day, Anthony. Oh, you'll be back, okay. So if I plug in 1 for y, x is 3. If I plug in 2 for y, x is 9. If I plug in 0 for y, still get 1. So let's plot the purple point. So the purple graph has this point 1, 0. And then it has when x is 3, y is 1, 4, 5, 6, 7, 8, 9, y is 2. So the only thing is that the graph is, and I could do the negative side too, but Jennifer is absolutely right. This will still have an asymptote, vertical asymptote, excuse me, at x equals 0. Because still, it is not possible for me to plug any y in to get 0. It's not possible. This will just be a little bit steeper. If the base is lower, the graph is a little bit steeper. I'm not going to belabor that point. I'm just going to do a quick drive-by because it's not super crucial. But the shape is the same. Shape hasn't changed. It's just graph is a little steeper. So any questions on these log graphs, the parent log graphs, if you will? Okay, cool. Let's stop this. We'll go to this board.